Okay, here we want to use the critical points to sketch the graph. The critical points are really good to just get a rough sketch of the graph. Now, we know this is a parabola because of the x squared. We also know that this is a parabola opening upward because the x squared here is positive. Okay, that's positive. And we know that the y-intercept is 3. So those are some of the things that we can tell directly. Now, there are 3 ways to do this. The first way that we learn, we make an x and y chart. That was pretty much the first way that we learned how to do it. And we put in all of our endpoints on x, and then we get our outputs. That was a good way. It worked, but it was very inefficient. Another way we could use this is to use the negative b. H is equal to negative b over 2a. And then k, we plug this back into our original function. So if you remember those ways work. So there's nothing wrong with it. But another way that we can do this is just using the critical points. So now, the first thing we want to do, we want to find the derivative and set it equal to 0. The derivative of x squared minus 2x plus 3 is 2x minus 2 equal to 0. That means 2x is equal to 2 and x is equal to 1. This is our critical point. The critical point is very, very important. All right. So now what we do, we can plug our critical point back into our original, but we're just going to hold up right here. So now we set up our timeline. Our number line, I'm sorry, not timeline. We plug a 1 in. We want to use our test values. I'm going to use 2 test values. I can use any number less than 1. In this case, I'm going to use 0. Use any number greater than 1. In this case, I'm going to use 2. And I want to plug this back into my first derivative. If we plug a 0 in, 2 times 0 minus 2 would give us a negative number. 2 times 2 minus 2 will give us a positive number. So that lets us know we're going to have a relative minimum at 1, and we need to plug 1 back into the original. So we have 1 squared, which is 1, minus 2 times 1, which is negative 1, plus 3. So we have a relative minimum at 1 and 2. That's over 1 up 2. Now, one thing that we knew that our y-intercept was 3. So we knew it was going to cross here. So the only thing we do just to get this rough sketch, we come down through our intercept, we come to our relative minimum, and after that, just like the graph says, it's going back up. All right. So this is just another way to get a good rough sketch when we're graphing functions. And it's especially useful when we have higher order polynomials like x to the 5th or something, of x to the 4th. So we can generally use those points and use those critical points to see where our function is increasing, where is it decreasing, and things like that. So in this case, we know, as we mentioned before, it is decreasing from negative infinity up to 1, but it's increasing from 1 to infinity. Okay, like we said, it seems like a lot when we're doing a parabola here, because we, could have used the XY chart, or we could have used the negative b over 2a that we learned in pre-cal. But I want to show you this just to see what was going on. But like we said, it's very beneficial when we have higher order polynomials, so we can see how it's increasing or decreasing.